All right, glad to see you all. Today I'm going to talk about something that we see every day and something makes us to see things every day. So what would that be?
Light.
Any guys? Yep, exactly. Thank you. Today I'm going to talk about light. Okay. So before I even start, I want to ask one question first. So from a physics perspective, what do you think why we can see things from a physics perspective? I know we have eyes, right? So what is beyond that that makes us to be able to see things? Yeah.
It's like the light when it's on some subject, it will reflect the light to your eyes. It makes you look.
Yeah, exactly. Very good. That's one part of it. So first, I'm gonna talk about the light source. So, as she said, one of the category of light sources called what I call light reflecting objects. Okay, so what about the other one? The other one would be light emitting light source. Okay, let's talk about the difference between each two. So light emitting objects, a very good example will be the sun, right? There is a nuclear reaction inside the core, so it emits the light and the photons from far, far away in space, and then those light travels through the universe and then reach the Earth and then illuminate the part of the Earth alternatively, right? One side and the other, right? So one of the good example of light emitting light source is the sun. Another one will be the light bulb, right? So the light bulb, when let's say a traditional tungsten light bulb, when you turn on the electricity, the current will go through the filament. The filament will start getting hotter and hotter, then it will emit light, right? So for the light emitting light source, it basically can emit light by itself. Okay, what about the other one? As she said, the light reflecting objects. Let's do a little experiment over here. Okay, so can we see each other right now? I mean, if you ignore the little light from this little window, basically we can. Yeah, as Alex said, almost cannot. Okay, let me turn back. So why we can't see each other when I turn on the light?
Because there is no light.
Yes, exactly. Yes, can you say it again?
There is no light, so you cannot see anything.
Right, because all of us, as human beings, we cannot emit any light. So we have to reflect some light from other light source and into our eyes to see each other. And the same way as the table or the chair, they reflect lights into our eyes so we can see them. When I turn the light source off, because we cannot generate any light, or the table cannot either, so we won't see them. That makes the second category of light source, that's the light reflecting light source. Then we have talked about how we can see. Then the second topic I'm going to talk about a very interesting feature of light, that is color. Okay. Light is made up of different colors, and in physics we use a quantity to describe the color, that is wavelength. Well, if you don't quite understand what wavelength is, you can think about the pitch of a sound analogically. So a pitch identifies a sound, same way a wavelength identifies a color. And in this world, to our human eyes, there is a range of wavelengths that we can see, what we call the visible wavelengths. That is from 390 nanometer to 740 nanometer. Nanometer is a very small unit. That's one of a billion meter. So it's very small. And then this is a visible range we can see. Okay. Now I'm gonna ask another question. Give me a guess. If we pick the color purple, and if we're gonna find the color purple in this range, where do you think it is? It is on the short side or it is on the long side?
The long side.
The long side?
700 nanometers, I think.
Okay. So any other
Short
thoughts?
side.
Short side?
Short
Yeah.
side.
Short side? Okay, actually it's on the short side.
On the short side.
Yeah, it's on the short side. The purple,
Oh, I got it.
purple will be here. On the long side, it is the red. Okay, so what about anything in between? There is, after purple is blue, and green, and yellow, and orange, then red. Okay, and then there are a lot of others next in between. So, but this pretty much is the visible wavelength range. Okay, and another property related to wavelengths is the energy of light. Okay, shorter the wavelength is, the more energy the light carries. So, for example, in summertime when there is clear sky, people usually put on sunscreen on their skin to protect ultraviolet, right? Because the ultraviolet from the sun can cause sunburn on your skin, and it can also cause damage to your eyes too. Why is that? It is because the ultraviolet, or we call it UV, is beyond our visible, but it has even shorter wavelengths than this, so it carries more energy, and then the energy it carries can damage our skin and our eyes. Okay, so we want to protect ourselves from those kind of light. Okay.
So I have a question.
Yes.
So you said that the UV is a light, so even we cannot see it, it's still called a light?
That's a good question.
Yeah.
I would say, in a scientific way, maybe you should not call it a light. Because we didn't talk about what is light.
Yeah.
We didn't talk about what is light. It is a little complicated to talk about what it is light. In modern physics, after we introduce quantum mechanics and electromagnetism, we say light is an electromagnetic wave. It has wave-particle duality. This is a little complicated, it's out of this range. But for UV, it is another kind of electromagnetic wave. But sometimes, in general, we still call it light, although we can't see it. So
Okay.
that's just a rough answer, I would say. But not too scientific, though. Okay, I think that's all pretty much I'm going to talk about today. And is there any other questions? All right, thank you.